All right, here we go. So last week you guys had 3 assignments. Several of you have not yet done any of your work from last week. So guys, please, you got to stay up to date with all of your assignments. No one should have any zeros ever. Okie dokie. This is kind of a short week since we don't have class tomorrow or school tomorrow. You only have 1 assignment this week. Simple. It's so easy. So last week we focused on unit rates. So you had to look at different prices and you had to figure out which of the prices was actually the better buy. So like I said, if you have not done last week's work, do it today. So here's a good example. I wanted to start with this one because we're not used to seeing a fraction written as a fraction. So if you ever have a fraction and either the numerator or the denominator is also a fraction, it's called a complex fraction. So let's look at this first example here. It says Juliet walks half a mile in 1/4 of an hour. How far does she walk in 1 hour? So just like last week, even though they're fractions, we're doing them the same way. We would put her, remember we were talking about miles per hour? So you're going to divide the miles by the hours. So even though they're fractions, it's still the same type of math problems. All right, so here's our distance, half a mile, and our time, 1/4 of an hour. And so then we can set up another ratio on the other side of the equal sign, distance over time once again. So how would I solve this proportion? What am I going to do? Go ahead and unmute if you know the answer. How do I solve proportions?
You're gonna divide either the time by the distance, or you're gonna multiply, or you're gonna divide the distance by the time. Which?
Yeah. Well, the way that we know for sure, Nevaeh, thank you for that, is you always can cross multiply and then divide by what's ever attached to the variable. So 1 times 1/2 is 1/2, right? What's 1/4 times x? 1/4 times x is 1/4 x. Yep, thank you, Evan. And then whatever is being multiplied by the variable, which in this situation is 1/4, that's what we divide by. So we're going to divide 1/2 by 1/4. And we're going to divide 1/4 x by 1/4. So basically all that does is it gets rid of our 1/4. My pen doesn't want to cooperate. But anyway, what we would have is x. So we can divide 1/2 by 1/4. So remember when we divide fractions, we're going to keep it, change it, flip it. And then we'd multiply straight across. So 4 times 1 is 4. 2 times 1 is 2. And can I simplify 4/2? What's 4 divided by 2?
2.
2. 2 what? 2 miles per hour, right? So if Juliet walks half a mile in 1/4 of an hour, it makes sense that she would walk 2 miles per hour. Any questions about that? Everybody good? All right, so we look at the slide deck. They did the same thing we did, and it says that x is equal to 2 miles an hour. All right, so let's look at these. Vu bikes 36 miles in 3/4 of an hour. How many miles per hour does she travel? And then look at letter A, excuse me, on the right side, it says a plane travels 150 miles in 1/3 of an hour. What is the unit rate? So I want everybody to try those 2 problems. And I want you to chat me the answer. So basically on both of these, even though they're fractions, you know how to divide by fractions. On both of these, you are dividing the miles by the speed. All right. Everybody send me a good question, or excuse me, answer. Everybody send me a good answer, please. Looking for answers in the chat, you guys. I'm looking for 2 answers. Good, Kaylee, you got the first one. Excellent. Isabella, that's a little too much, sweetie. Try that one more time, please. Good, Jeremy. Good, Karen. Good, Nevaeh. Oh, I'm sorry, Isabella, you got the second one right. I thought you were answering the first question. Yep. You got the second one right. No, you had it right the first time. I apologize if I messed you up. Oh, now you got both of them. Good, Isabella. Lily, wakey, wakey. Give me some answers. Good, Wyatt. That's right. Good. Good, Nevaeh. Layla, try that first one more time, sweetie. Make sure you're dividing by 3/4. Good, Kaylee. Good. All right. All right, so basically, guys, just like we did last week, we're dividing the miles by the speed. Good, Nevaeh. All right, so on the first one, if Vu goes 36 miles in 3/4 of an hour, we're dividing 36 by 3/4. So what does that look like? Good, Karen. We're doing 36 divided by 3/4 of an hour, 3/4. And then how do you divide fractions? You keep it, change it, flip it. Or in your calculator, you can simply divide 36 by 3/4. And the answer is, what is it? 48. She is going 48 miles per hour. She is flying on that bike, you guys. I don't think anybody can actually ride a bike that fast. Do you think? I don't think somebody can ride a bike 48 miles an hour. Maybe there's a small engine on it. All right, what about the plane? The plane travels 150 miles in 1/3 of an hour, right? 1/3 of an hour. So we're going to have 150 divided by 1/3. So what does that look like? 150 divided by 1/3. And then in other words, what are we going to do to divide fractions? We're going to keep it, change it, flip it. So basically it's 150 times 3, which is 450 miles an hour. Does that make sense for an airplane? Now, if we ended up that with a car or a bicycle, I'd be going, whoa, something's wrong, but it's a bike. I meant it's not a bike, it's a plane. All right, so then if they're going 450 miles in 1 hour, how long would it take them to go 1,350 miles? Someone tell me what to do mathematically.
You divide.
You divide. You divide how many total miles they're going by their speed, miles per hour. We're dividing by 450, and the answer is it would take them 3 hours, and a lot of you got that right. Good job. Okay, so don't be scared of fractions. Even though it's fractions, we're still doing what we did last week. We're just dividing. Last week we focused on prices. So last week we were focusing on the total price divided by the quantity. These are just complex fractions, no big deal. We can do those. Someone needs to mute. I can't see all of you at once, so make sure you're muted, please. All right, guys, now that you know all about rates and unit rates, let's see how we can recognize proportional relationships. So how can we show that two units are proportional? Let's look at some examples together. Professor Floyd is planning an end of the year pizza party for his students. The cost of pizzas at the corner pizza place is shown at the table on the right. Here we go. So this says if we buy one pizza, the cost is $8. If we buy two pizzas, the cost is $16, three pizzas, $24, so on and so forth. So for each number of pizzas, write the ratio of total cost to the total number of pizzas, then simplify. All right, so it's telling us that to check to make sure these are proportional, we're going to divide the cost by the number of pizzas. So it's going to cost $8 for one pizza, $16 for two pizzas, $24 for three pizzas, and $32 for four pizzas. Do you believe that all of these ratios are equal? What if I simplified all of these? Would they be the same number? A nod or a shake? Yes or no? I see a couple of nods. Yes, if I simplify all of these, what isn't 8 divided by 1, 8, and 16 divided by 2, 8, and 24 divided by 3, 8. So when we divide the cost by the pizza and we get the same unit rate, that means that this graph this table represents proportional relationships. So now there's a new term we're going to learn. It's called the constant of proportionality. Since all of these ratios simplify to the same number, that means they're all proportional, and the constant of proportionality is $8 per pizza. Okay, that's a long term to say what do they all simplify to be. All right, so the work here agrees with what we said. What do we notice about the simplified ratios? They all simplify to the same number, which means that is the constant ratio. So when you have a table, like here, we have two tables here, one about Martin reading pages and Gabriel reading pages. In order to find out if the table represents a proportion, it's a proportional relationship, that means you have to divide the bottom number by the top number. In other words, if this was an XY tables, to find out if two tables represent, or a table represents proportional relationships, if you divide Y by X and you get the same answer every time, it means it's proportional, okay? So that's what a proportion is. It's two quantities that have the same constant rate. If it's not proportional, that means sometimes when you divide Y by X, for any one of them, you could get a different number. For example, let's do Y divided by X. So Martin read 5 pages in 2 hours. He read 10 pages in 4 hours. He read 15 pages in 6 hours, and he read 20 pages in 8 hours. So I know that 5 divided by 2 is 2.5. Right? What's 10 divided by 4? Somebody use your calculator real quick. What's 10 divided by 4? Karen said 2.5. I'll put it down here. Somebody divide 15 by 6 and tell me what you get. What's 15 divided by 6?
2.5.
Is it 2.5 as well? And then let's divide 20 by 8. And what do we get?
2.5 as well.
2.5 as well. So guys, every single time we divided Y by X, we got the same answer as 2.5. So that means this table right here represents a proportional relationship, proportional relationship. And the constant of proportionality is 2.5. In other words, Martin read 2.5 pages per minute. Okie dokie. All right, let's see if Gabriel was reading consistently. So he read 5 pages in 3 hours, 10 pages in 4 hours, 15 pages in 7 hours, and 20 pages in 9 hours. All right, so what's 5 divided by 3? Karen said it's 1.6. So we'll put 1.6. All right, what's 10 divided by 4? So 10 divided by 4, we did it up here, didn't we? It's 2.5. So the very first time you see the two rates are different, you know that this does not represent a proportional relationship. Okay, and the way you check it is by dividing y by x. So Martin read at a constant rate and Gabriel did not. Gabriel did not read at a constant rate. Does that make sense, you guys? Yes? I got 1 thumbs up. Okay. I got more thumbs up. Awesome. All right, what questions do you have right now? Any? No, no, no. Okay. All right, let's see what it says. Hey, look, we were right. Martin read at a consistent rate. We got it, dude. All right, so after our lesson, if you need to come back and watch this awesome video about proportional relationships, please do so. We're not going to take the time right now to do it, though. Oh, no. All right, so how can we show that 2 units are proportional? Let's look at an example together. An adult elephant drinks about 250 liters of water each day. Complete the table to the right. So on day 1, the elephant would drink 250 liters, right? So after day 2, how many liters of water would the elephant drink? What's 250 times 2? 500. Good, Evan. What about, good, Karen? What about day 3? How many liters of water total would the elephant drink? 750. Good, exactly. And then day 4, the total number of liters would be 1,000. So let's look at letter B. Is the number of days the water supply lasts proportional to the number of liters of water the elephant drinks? So if we divide 250 by 1, we get 250. If we divide 500 by 2, we get 250. If we divide 750 by 3, we get 250, so on and so forth. So does this represent a proportional relationship? Yes, absolutely. Since they're all equal to 250, that means that the number of days and the water supply are proportional. The constant ratio that they all simplify down to is 250. So that is our constant of proportionality. You got it? Excellent. All right, there's another awesome video, or is that the same one? Am I going the wrong way? Am I going the wrong way? No, I was not going the wrong way. All right, so we've looked at comparing 2 tables. Now we're going to look at comparing a graph to see if the graph represents proportional relationships. When looking at a graph, 2 quantities are proportional if 2 things happen, guys. 2 things has to be true about a graph. Number 1, it must have a straight line on it. Do you agree that both of our lines, the blue and the red one, are both straight? Yep. The second thing a proportional relationship shows on a graph is the line must go through the origin, 0, 0. So even though both lines are straight, do both of these lines touch the origin at 0, 0? No, only the red one right here. If I gave this point right here a specific name, it would be 0, 0. So if you go to the fun center and you pitch 0 balls, it's going to cost you $0. If you have a total of 4 pitches, it's going to cost you $1. If you have a total of 8 pitches, it's going to cost you $2. Okay. However, if you go to Softball Plus, even if the number of pitches is 0, do you still owe $0? No, you would owe $3. If you had 6 pitches, you would pay $4. So even though the rate might be going up the same, they don't start in the same place. So basically, Softball Plus is going to charge you $3 for coming in, and then they're going to charge you per pitch. Fun Center is only charging you by the number of pitches that you throw. So only the red line represents a proportional relationship because it is straight and only the red line goes through 0, 0. Okay. Since the blue line does not go through 0, 0 right here, it means it's not a proportional relationship. Any questions about that? So it's easy. It's very easy on a graph to pick out a proportional relationship because as long as it's straight and as long as it touches 0, 0, it shows a proportional relationship. All right, so who can tell me what the price per pitch is at Fun Center? What is the price per pitch? So if I throw 4 pitches, I owe $1. And if I throw 8 pitches, I owe $2. What is the price per pitch?
$2.
$2 per pitch. So in other words, if I throw 4 pitches, I owe $8. Is that what it says? $2 per pitch? So all we're doing is dividing the number of pitches by the cost. If I divide a 4 into 4 equal if I divide $1 into 4 equal sections, how much money is it? 20, good, Kellen, is 25 cents per pitch. Good, Isabella, 25 cents per pitch, right? Good, Sophia got it too. Doesn't that make sense? 4 pitches is $1, 8 pitches is $2. That means each pitch is 25 cents per pitch. Okie dokie. All right, good job. All right, it says we can also transfer points on the graph to a table to decide if they represent a proportional relationship. So this ordered pair right here is 0, 0. This ordered pair is 4, 1. This ordered pair is 8, 2. Y'all remember when you started learning how to graphs and coming up with the coordinates? All right, so let's do that. Let's look at Softball Plus. So remember, you have to divide y by x. So if we do Softball Plus, if we do 4 divided by 6 and 5 divided by 12, are these equal? Somebody figure out real quick. What is 4 divided by 6 in money? What's 4 divided by 6 in your calculators? Karen said it's 4 divided by 6. Isn't it 0.6666666? Which is 67 cents, right? What is 5 divided by 12 in your calculator? What's 5 divided by 12?
0.4166667.
So about 42 cents, right? We round that to about 42 cents. So right here, this tells you that the blue line is not proportional because the prices change. If I could write well enough for you to read. Okay. However, if we took the information from Fun Center and we divide 1 by 4, and if we divide 2 by 8, and we divide 3 by 12, for every one of these, don't we get 0.25, 0.25, 0.25, which is our price. It's 25 cents per pitch. Oh my goodness, my writing is getting worse the more I do. All right, are y'all listening? You understand? I think like 3 of you are like giving me answers when I ask questions. It makes me think that some of you aren't listening. It worries me a little bit. No questions? Okie dokie. All right, moving on. They're showing the same thing we just did and the same conclusion. Softball Plus does not have a constant ratio. However, Fun Center does. Okay, here we go, everybody. We're going to turn this table into a graph, and then we're going to decide, is this an example of a proportional relationship? So the number of weeks is our horizontal axis, and our balance is our vertical axis. So in 1 week, we saved $125. So I'm going to come over here to 1, and I'm going to go up to 125 right there. 1 week, $125. Then it says in 2 weeks, we've saved 150. Here's 2. I'm going to go up here to 150. All right. And then 3 weeks, we saved $175. So if I connect my dots, do I get a straight line? Do I get a straight line? I do get a straight line. Do you think this is a proportional relationship because it's a straight line? Well, it is a straight line, but what do proportional relationships have to look like on a graph? What's the other criteria? Remember earlier we were talking about it? It also had to go through 0, 0. Does my line go through 0, 0? No, so this is not a proportional relationship. Now, how can I be extra sure? I can divide, if this is my X and this is my Y, remember, I can always divide Y by X. All right, what's 125 divided by 1? What's 125 divided by 1?
125.
Yes, good, Jen and Kate, 125. What if I do the other one? Y divided by X, remember, what's 150 divided by 2? Is it also 125?
75.
75. So once again, we've proven that this is not a proportional relationship because the constant of proportionality doesn't exist. If you ever get a different number for any of them, Y divided by X, it means this is not proportional. Okay? So you can prove it by using a graph and a table. What questions do you have? Nothing, nothing, nothing. Okay. All right, so same thing. All right, let's check out the constant of proportionality. So I've already been using that term, constant of proportionality. So once again, here's a table. In 1 hour, this person eats 4 nuggets. My goodness, that person is a slow eater, right? In 3 hours, this person eats 12 nuggets. In 5 hours, this person eats 20 nuggets, so on and so forth. So the first thing we would do to figure out, is this a proportional relationship, is right here, guys, we're going to divide Y by X. We're going to divide Y by X. So 4 divided by 1 is 4. 12 divided by 3 is 4. 20 divided by 5 is 4. So because they divided Y by X, I wish these were always labeled. So this is always X. The first one's always X. The second one's always Y. Since we divided Y by X, we got 4 each time. That means that this represents a proportional relationship. And that number 4 is our constant of proportionality. That's our constant of proportionality. Okie dokie. All right, and here is, I don't like that proportion. All right, so this guy on this video, if you're confused later in the week when you do your one simple assignment for the week, and you can't remember what is constant of proportionality, come back and watch this video that's embedded in the slide deck. All right, so you can find the constant of proportionality when the data is represented in a variety of forms. Remember, all that means is finding the unit rate. So here we have a table. When x is 2, y is 16. When x is 4, y is 24. When x is 6, y is 32. And in order to find the constant of proportionality, you're going to put y over x. It's like you're flipping it, really. You're flipping it. Okay, who already knows what our constant of proportionality is? Okay, thank you, Jeremy. Or Luke. Thank you, Luke. Who already knows our constant of proportionality of this graph right here? Good, Karen. Does anyone else know our constant of proportionality? Only Karen? How do we get it? What do we do?
You divide y and you divide x and you get 6 for each one.
You get 6?
Or
What's 16? What are we going to divide here? 16 divided by what?
2.
2, which is what? What's 16 divided by 2? 8, right? Yep, 16 divided by 2 is 8. 24 divided by 4. 24 divided by 4 is not. Oh, this one isn't proportional. Oh my goodness. I didn't even do it in my head before I did that. Yeah, so this is not, this does not represent a proportional relationship because 16 divided by 2 is 8. I looked at it too quick, you guys. 24 divided by 4 is not 8, it is 6, right? That's what Nevaeh was telling me. And 32 divided by 6 is not 8, it is some fraction, right? What's 32 divided by 6 is what? 5.3. So this table does not represent a proportional relationship. Okie dokie. All right, so it says right here, moving on, form an equation, find k. It's also the coefficient of x. So from a table, if this were proportional, this would help us, which is not proportional. I think I put in the wrong table there. From words, you can make a proportion. If 280 students were on 4 buses and 70 students were on 1 bus, as long as you find the unit rate, if the denominator is 1, we know our constant of proportionality is 70 because 280 divided by 4 is 70. And then it's always, anytime you have an equation where y equals a number times x, the coefficient of x is the constant of proportionality right there. So for example, if I said, let's say I make a table and I say that we're going to buy football tickets. And so I'm going to let x be the number of tickets. And I'm going to let the y value be my total cost. And what if I tell you 1 ticket is $7, 2 tickets is $14, 3 tickets is $21. My equation would be, if this is x and y, my equation would be y is equal to 7 times the number of tickets, right? Well, when it's written in this form, when my equation is written in y equals form, whatever number is multiplied by my x, that is the constant of proportionality. And in this situation, it's 7, right? How do we get our constant of proportionality? It'd be y divided by 7, y divided by x, y divided by x, and y divided by x. On all of these, we would find our constant of proportionality is 7. Okay. All right, so here's another example of a graph that shows a proportional relationship. As long as your graph has a straight line, and the other criteria is that the line must touch the origin at 0, 0. That means it's proportional. Okie dokie. What time do we get out of here? 11:30? 11:30. Oh, we're almost out of time. All right, so you have 4 different ways of finding the constant of proportionality from a table. If I would divide in y by x, With words, you could make proportions this way. As long as your denominator is 1, the top number is your constant of proportionality. From an equation, y equals a number times x. Whatever number is being multiplied by x is your constant of proportionality. And from a graph, as long as it's straight and goes through the origin, it is proportional. Okie dokie. So let's look at number 1. Actually, you know what? We're going to get to this on Wednesday because this looks a lot like your assignment that you're going to have on Thursday. So I'm going to stop it right there. And then let me go ahead and pause the recording.